Hi, welcome to Tech Phantoms. This is MLSA Event 3 powered by Tech Phantoms and Microsoft Learn Student Ambassadors. Tech Phantoms is an open source community where we build open source projects and also help students to learn real world software development. And this is an event where we are going to see how machine learning works. We have expert speaker Inderpreet Singh. He is MLSA plus ACM students chapters executive member board. So let's get started. Inderpreet Singh, over to you.
So good morning everyone, good evening everyone. Thank you for the warm wishes I can see in the chat box, and hope I am would be worth it for your time. Okay, so straightway let's start with machine learning. So what is machine learning? So machine learning can be defined as a field of computer science that gives an ability to learn explicitly without being programmed to a computer. So in one line, we can say that machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. The process of learning begins with observation of data as examples, direct experience, or instructions in order to look for patterns in data and make better decisions in future based on examples we provide. Now the primary aim of machine learning, AI, or deep learning, machine learning and AI are the branches of machine learning and deep learning are the branches of artificial intelligence only. It is to make the computer self-sustainable, or to give them the ability to make their decisions on their own, just like humans. This single sentence can sum up the whole process of machine learning as well as deep learning. The programming aspect, the mathematical aspect, are both the different things. Okay, so if saying in some technical words, we say that machine learning uses data for answering the questions, where answering the questions refer to predicting, and using data refers to training. I hope I'm not so fast. uh, Okay, so now machine learning can be divided into three parts: supervised learning, unsupervised learning, reinforcement learning. Now, in most of you who have been doing machine learning, or you have just listened about it, it is most famously we can say it is divided into supervised learning and unsupervised learning. Reinforcement learning, for I think for introductory level, is not a good thing to learn, although it has great usage in the industrial departments. Okay, so let's start with the supervised learning. The name supervised learning originates from the idea that algorithm is teached by an teacher. Okay, so it can apply what has been learned in the past, and it try to use that past experience or the past knowledge to predict the future. So what I want to say is that in very simple words, in data set words, we can say that supervised learning works on labeled data. Starting from the analysis of an known training set, the learning algorithm produces an inferred function to make predictions about the output values. So what I want to say is that supervised learning try to fit a mathematical function, or in very simple words, it want to fit a line which can satisfy the x and the predicted and the required y outputs. I will go into the line fitting model in quite detail. Actually, this is the one project we would try to build today. Okay. uh, next uh, Next, let's discuss about the types of supervised learning. Now, supervised learning can be divided into classification and regression problems. A classification problem is just like since most of you are from mathematical branch, I can safely say it is about somewhat like binary problems. Either the answer is 1 or 0. Similarly, Let's take an example of data. We have lots of fruits, and we have an algorithm, or we can say a black box machine. We put a machine, and we keep on telling the algorithm that this is an orange, this is a banana, this is a mango. So what then algorithm does is learns on what types of characteristics like color, size, softness, taste, all those hypothetical things, on the base of which he can give us certain outputs. Now in classification, the number of outputs are same. He can only the machine algorithm can only give the output like banana, apple, or orange, nothing else. But now when we say about regression gives the answer in real values. The most easy examples of real value are dollars, I mean money, weight, pressure, and atmospheric pressures, and all other things which are measured, which can be measured in real values. Now regression is a quite used thing, but and classification is also quite heavily used. But today our subject would be mainly focused on regression. If you have any doubts, you can say in chat box also. I will be seeing it there. Okay, so I can move forward. Okay. Now let's say about human supervised learning examples. Okay, so like you can see it there: house prices, cat or dog, weather today, who are the unhappy customers. Now let me briefly explain about these examples, as these are the ones, once you get a little bit matured in machine learning and deep learning, these are the ones you would be going through in your daily routine of machine learning. So talking about house prices, in this, consider that we have a house. I have a house of 150 square yards, and its color is white. Okay, it is sun facing. So these three are the characteristics. So what are its characteristics? We have divided it on the basis of size, on the basis of direction, on the basis of color, and along with this we would give that this house was sold for rupees 10,000. I'm sorry, the houses are sold for very high, but just for the sake of example. uh, and similarly we give the house prices of other 2000 houses to our algorithm. The algorithm feeds the data, understands the characteristic relation, tries to fit a model, or what we can say is a equation, a linear, not a linear equation, but in our case today's project we would use linear equation. So it would try to fit a linear equation there, and for next time, for example, for an unknown house whose only characteristics are known, we can predict at how much price it can be sold out. By just listening this example, you can understand that such a large business implementation of machine learning and deep learning can be there. Next is the cat or dog problem. It can be divided into classification problems. Then weather can be in a now weather is a regression problem, because if we follow closely to the weather, uh, the pressure, atmospheric pressure, the amount of rain, and all those come, which have a real world value. Okay. Next, who are the unhappy customer? Now this is the the hot topic of current industry. The website or the industry who can understand who are the unhappy customers can find how to give that they can then understand how to give them better services. So one particular popular topic in this was text classification. How is text classification related to it is that we understand the negative commenting of the customers, and then we act upon it. And other than that is star rating, and how much they sell or purchase in past few months, and all those other stuffs. Next is unsupervised learning. I won't go into detail in much, but this is a really good topic to be understood. Now, in unsupervised learning, the problem is that we don't have a teacher. Now, what do you mean by teacher is that we don't have a labeled data. We have abundance of data. Uh, just for information's sake, there is two types of data mostly divided into, is SQL or non-SQL, that is structured or no structured data. Structured is the one like you see in tables or SQL files for database people who can know database. And unstructured is the one like comments, ratings, likes, other just views on the reviewing system. All this goes into unstructured data. 97% of the data is unstructured. So we have lot of abundance of data, but we don't know what to do with it. Here the supervised unsupervised learning come into play. Now in unsupervised learning, the main idea is to you know the main idea is to uh, learn to understand the patterns of the data without any teacher. Now you would think that how is this possible, but in this case we are not totally into the dark. Let me just just explain a bit. Now we do this kind of learning every day also. For example, we don't know about things, or we for example just say, consider a graph. Consider a graph, we have some points at the top of the graph, some at bottom, some at right side or left side, anywhere. Just imagine if we have if we can put a circle on the right top, on the bottom right, and all those places. So after circling these things, what we can say that we have segregated the top, bottom, and the right ones. Now what we just did, this process is known as clustering, one of the key concepts of unsupervised learning. uh, so in thus by clustering, this is what the computer does. It clusters the data. Now what clustering will help is, after clustering a abundant of data, it would be easy for the humans to understand, okay, so this type of data has been segregated. So after that, after segregation, the humans can easily work upon it, can label it, or do all such of things of problems. Now it is for sure that unsupervised learning is not as easy as supervised learning. It have some problems, like how do we one of the main problem is, how do we even know that if the results are meaningful, since nothing is labeled. Okay. Other than that, even for labeling or after clustering, we need an expert who is uh, who in the domain. Here domain means the problem statement on which we are working. For example, if we are working in share market, then we need a share market expert. For if we are working in online education, uh, machine learning algorithms, then we need an online educator, or the experts who are handling these types of field for a long time. Okay. So here are the few examples for unsupervised learning. Any doubts up till how? Yeah. Okay. So finding customer segments. Uh, Now this is the one of the most, I believe, beautiful example of unsupervised learning. In clustering, an unsupervised technique where the goal is to find natural groups of clusters. Okay. Okay. So next is that if okay, I will just explain customer segments once again. Consider that we have 15 people who can buy from any site, Amazon, Flipkart, and most of them out of 5 of those mostly buy the sports stuff, others buy cosmetic, other buy fashion material or clothes, anything else. So after a 2 months of data we have, we can easily divide that those customers according to their wishes. And since we have now clustered, we know that after the domain knowledge expert sees that data, he can easily tell that this is that they need sports. So the algorithm, or you can see in Amazon also, they already start to give you advertisements of the sports and all those things. Okay. And next is the reducing the complexity of a problem. Now this is also known as dimensional reduction. uh, this is a commonly used technique in unsupervised learning. One of the most common use of dimensionality reduction is to reduce the complexity by projecting the feature space to a lower dimension space so that less correlated variables are considered in machine learning. I think so. Don't get deep into it. Okay, the last one is feature selection. Even assume that we want to predict how capable an applicant is of repaying a loan from the perspective of bank. So this is one of the main areas in which feature selection can work in case of unsupervised learning as well. Okay, next. So now I wish okay, I would just briefly tell about res- just a minute. Okay, so we will start with linear regression. Just a time. Okay, so we will directly start with linear regression. This is the main topic of our project. Okay, so as you can see, my cursor is visible. So as you can see, we have fitted a line y equals to mx plus c for mathematical branches, and all those points you can see here is the data. Is the data. What do you mean by data? Is that we have a x. Just if I consider a univariate, I will explain that later. That for a particular x, this is the given y value. Linear regression comes under supervised learning, as told earlier. So this was the best fit line. Best fit line was is that means that, for example, if I have put a line here, then that would be of no use, because once we try to find for an unknown value of x, our prediction would be wrong for the most of times. Okay. uh, in linear regression, if we talk in terms of definitions, it is a supervised machine learning algorithm where the predicted output is continuous and has a constant slope, and it is used to predict values within a common range. Examples are just like house prices, sales, companies, and other things. Okay. Now, linear regression can also be divided into simple linear regression and multivariate regression. Now, here, simple linear regression, uh, what it means is that we only have one variable. Considering our house prices example, now house prices, suppose we only judge the rate of house prices on the basis of the size of the house, then it would be only simple linear regression. But as the name suggests, linear, a line, a linear can be somewhat a curved line also, which would be in case of multivariate regression. If I talk about in terms of functioning, that functions, the predicted output value would be dependent on a single variable, and in multivariate regression, the predicted output would be you know dependent on 2, 3, or n number of variables. As you can see that here, a very simple line equation y equals to mx plus z b can be considered as a answer to linear regression problem. Okay. And here we can see we have x, we have y, we have z. These are the three variables on which our multivariate regression would depend. Example of multivariate regression based on our house price example can be that our house is dependent on size, color, and height of the number of floors or all other stuff. Okay. So, but the core idea is to obtain a line that best fits the data. I want you to please understand that the best fit line. This is the main concept. If you understand this, most of the part of linear regression or even machine learning would be very very clear to you. Okay. So next. So now let's dive into practical approach. Any doubts if there? Okay, no issue. Okay, so these are the major steps in development of a machine learning model, any type of model. Data gathering, one thing to be noted is, if you want to pursue a career in this, data gathering and data processing, pre-processing, are the most time consuming parts of the machine learning algorithm. Okay. uh, for a particular example, if I remember, one of my friend just recently did a project on machine learning on text analysis, I believe. About 1 month of their time just went on data gathering and pre-processing. Data pre-processing is itself a field where people work. Okay. Next is feature engineering. We won't go in depth into this due to introductory levels, but just in case, if you want to know what is data gathering and pre-processing is, data gathering is, as you know, we collect the data from web scraping, or we manually input the data, or we have in the form of forms, Google Forms, Microsoft Forms. And other than that, we have email data, and all those spidering the web, scraping the web. So this is how we gather the data. Now, we have gathered the data, that's fine, but our data is never good enough. A real life data set is never good enough. It is full of anomalies. Here the data pre-processing comes. Now data what why here data pre-processing is, consider the example of our house prices. We have three variables: size, color, and floors. And say we have 1000 number of houses, in which of which we have data. Okay. And consider that out of which the 10 don't have the sizes correct, or we have blank sizes, we have blank floors, we have invalid floors. Someone some house -1 floors are written. That is totally ridiculous. But this is how in real life or practical approach the data is there. So here the data pre-processing comes, in which we correct the data. For example, if we have zero size, we have a number of floors to be zero, or nothing. So in this case, what would we do? How to make that data constant or good enough so that our algorithm can use it easily? In this, we have various approaches. We can enter the mean of all the number of floors, we obviously in integer form. And other than that, for example, if we don't have the size, we can have also have the mean, we can have the maximum value, we can have the maximum frequency. For example, the maximum houses have the frequency of 3 floors, so we will write here 3, just to make our data set constant. There can be a question in your mind that why not we can delete the entry. But in today's world, the data is really costly. Data gathering and data processing is highly costly, highly time consuming. So deleting a data is not at all a good thing. Okay, any doubts? Okay, thank you everyone for their warm wishes. Okay, so next is algorithm selection. Now algorithm selection at introductory level, you don't know, you won't go into this. But considering algorithm selection, if it is a classification problem, you can use knn, just for the basic ones. Knn model. For a simple single univariate, you can use linear regression. We can use multivariate. And you can use the concepts of deep learning. For example, up till 2011 or 12, when deep learning was not so famous, when a machine learning algorithm used to detect face, up only about 70% accuracy was achieved. But when deep learning came, so about 90 to 93% accuracy can be easily achieved in deep learning algorithms. Okay. So in today's class, our algorithm selection would be univariate linear regression or simple linear regression. Okay. Next is model training. Model training is the one when our algorithm meets our data, and uh, our algorithm modifies itself according to data. Here we would go deep into this for linear regression. But at the end of model training, algorithm takes out some really important weights. Here weights are the factors. See, consider that we have a x value which x which is from data, and the predicted y value. These both are constant. We cannot change these values. So we need to change something to fit a line, to fit any 2D curve or all those stuffs. So there are biases, there are weights. Consider that line is a like y equals to theta 1 x plus theta 2. Thetas are variables. So after algorithms, each algorithm iteration here means that we predict a value, we check with our the real value, and we make some changes to our algorithm. So after those n number of iterations, we would get the optimal values of theta. We would go into more detail in this. And lastly, it is making predictions. So our algorithm is ready. We can have then making predictions. How can we make prediction? Just for knowledge sake, consider that we have 100% of data divided into 80% and 80% training data, 10% validation data, and 10% test data. If the data is very very large, or 70/30 of training a test can be good. This would be based on your data or the algorithm, but this would be a really no, long away if you are at introductory level. So finally, we are at model fitting. Before that, if anyone has any doubt. Okay. Okay, so we would start here. Now, model fitting. This is the thing which I want you to understand. Consider that, for example, this is our x value, that is our data, and this is the predicted from our data. So suppose we have line, and for example 50, consider this point 50. At 50, our line would almost predict, I think, 1, but the real values can range from 6 or 7. So see the difference. A 5 point difference in machine learning means a lot. So why is this so? The line is not even passing through the data, not even touching one except one data point. Each data set, for example, each price and price and the characteristics of data of a house is known as one data set example. Okay, so this line is completely disregarded. If considering about its accuracy, it is just 2 or 3%. Next, now one thing, initially our algorithm would mostly give this line. On the very first iteration, our algorithm would mostly give this line only. Next, our algorithm saw that we have such a large difference, so we need to get this a little bit better. Now you can see, we can see that here the line is at least doing something, or can predict at least for few words. We can possibly say that we have achieved at least 20% of accuracy. Algorithm is still not satisfied, or the supervisor, the teacher, that is us, the machine learning engineers, are still not satisfied. Next, you see the line is going up. Going up doesn't mean anything. Going up here means is that it is getting close and close to each and every data point. How is the algorithm checks that is there any error or not? Like how much is the difference? So there is a mean square error. We would talk the mathematical detail later, but consider that this point at point 20, the algorithm gives 5, but consider that our answer, the real value, gives our answer 10. So 10 minus 5 is the 5. So algorithm sees that the difference is still 5, and the algorithm will calculate for each and every data set example. So now it will add it, divide by total number of examples. Total number of data set examples can be donated by m. In most general cases, you can donate it with anything. Okay, so there is a mean square error, I would talk about it later. So this is just give a simple understanding how it divides checks the error of its algorithm. So we are still not satisfied, but I think it has reached about 50% accuracy. So next, so this is the line. Although this is also 60 to 70%, but considering the 5% accuracy to 70% accuracy in some iterations, about like for example, if we say about five, not five iterations, but in real life like 50 or 60 iterations, so we have came a long way up. So this is how the model fitting is done. Okay, so here I think my PPT part would be over. For any doubts you can say. No, so, okay. What is one is there? What is the difference between machine learning and AI? Okay, so there is no difference between machine learning and AI. Actually, machine learning is a subset of AI. AI can be considered as a more larger perspective. In AI, we can have our machine learning as well as deep learning. uh, Initially it was AI, but when we go more and more into practicality, machine learning and deep learning comes into phase. Okay, and just for information, AI or AI is not a new topic. It is started in 1940s. Most of the CCT students may know that. Okay, so we are here. So I think we should start the coding aspect. Okay. So this is my command prompt. So today I will try to open my VS Code with the terminal. I hope many of you don't know that. So to open it, we write code. Uh, Now it is visible, I think. Yeah. So we write code. I hope it is visible now. Yeah, it is now visible, clear. We write CODE code, and then the uh, name of the folder you want to open. So welcome to Visual Studio Code. So I have been working on it from about like 1 year. This is my favorite one. You can I would recommend all to try it once. I would just explain the uh, interface briefly. So here is our folders. The folder we have just opened. These are the files in it. Okay, and from here you can install the extensions. In the previous version, the we need to install extensions explicitly, but now, as in the latest version of 2020 September edition, if you have got a new type of language just first time into it, it will automatically give you recommendations about please install this extension for better code visibility and code error checking. Okay, and next here, this is a file, the top bar, and I would just like to show you the preferences. And here, so these are the keyboard shortcuts. You can try on your own. You can edit it on your own. I have just the uppercase one, I have just uh, changed it. So earlier it was in a JSON file. Now it is I can say completely GUI something sort. And let's open our code file. And this is here to split the screen. And if you can see, just I can see now, it would be easily. Yeah, now it is easily available. So this was just to split the screen, and the small uh, vertical line you can see here is to go to the code. directly to the code. This feature is really handy in terms of HTML or long Python files or C files, in which you can directly go to the code based on your in on the coloring. Okay, and this is the play button for directly playing your file, and this is to view the changes you have made after once saving. I would try to show it a little bit later. One way to open the terminal is like directly, you can see here, or the control and this comma sort of thing just above the tab. I can't remember its name. So if here you can install the libraries or do whatever stuff you want to do. Oh, so I think we are done with the basic Visual Studio. Okay, so now let's start by discussing a few libraries. Let's start by discussing a few libraries. So now we can see that there are few libraries like matplotlib, numpy, panda, cbon, and mpl toolkits. Earlier this project I have built in Jupyter notebooks, but I would recommend you all to try and build it in a completely new .py file, as it would be just like implementing a model, uh, as it is quite more better than implementing in Jupyter notebook. I have implemented it in Jupyter notebook also. In Azure, I will show you a bit later. So let's talk about the few let's talk about a few libraries here. So here NumPy and pandas, whatever you want to say. So these are, I believe, the core or the backbone of any Python long project machine learning. Starting with NumPy. NumPy is a mathematical library, mathematical functions library. It is really very good with matrices, and matrices are one of the core concepts for machine learning. And secondly is pandas. Pandas is one of those libraries which can understand our data and help to the things I told you earlier, that data pre-processing, mostly it is done with pandas only. Other than that, cbon, mpl toolkits, matplotlib, these are the ones which we would use for visualization purposes of the graphs and other things. Okay. Just if you are new to Python, just I am hoping that you all have Python. So if you want to install any library, 90% of libraries, excluding some TensorFlow or deep learning major libraries, could be easily installed using pip install and numpy and enter. You should have an internet connection for that. Pip is the package manager for numpy. Oh, sorry, for Python. Okay, so requirement is already satisfied. I have already installed it. If you do, it would do some processing and would easily download. Okay, so we would cross this terminal and straight away go to our main function. Okay, before that, any doubts? Okay, nothing. Okay, so just a minute, let me explain you the data set. In this I have kept a .txt file. It is very easy data set. This is just, I think this is, considering it is a hypothetical data set, this won't be used anywhere. Mostly data set you would find on internet or on online courses would be in the form of .csv file, or you have to web scrap it and all other sorts of things. So I have just developed a problem statement. I would read it, that you are a CEO of a bike company or any manufacturing company. As all good entrepreneurs, you also want to expand your business in different cities. You have a data set of all the cities in which your business is already running. Dataset consists of population. This dataset consists of the population of the city and the company profits. Okay, and thus you want to know, like in future, based on the population, which city or country would be more profitable. Just a point to be noted here: 6.1101 means that the population is 61,101. Okay, I would explain you in bit time why is this. I think data set would be clear. I am crossing it. Okay, so now in this data set the population is the deciding factor. Okay, let's start with the function. Before that, if any doubts. Yeah, okay, we would start. So we have already imported our libraries. uh, so don't don't try it. You can try and code along. It would be very easy. I have kept the code quite small. So we would now start with main. Def main, I have just kept it just in case someone is from the C background only. Here the plot plt dot figure size equals to 12,8. Don't go too much into it. These are the just functions. You can easily find them from the documentations of all the visualization libraries. But here 12,8 means the window size we would open when we will visualize our data. Okay, next is the data received, or the file we have just shown you. Data equals to pd dot read underscore csv. Pd here means pandas. We can import it by putting in word as. This consider a library like this matplot.pyplot, and suppose you have to write it every time. So it is really very hard work, very long work. So this is a really nice feature of Python. I am sure it would be in other languages also. So I would just show you the data set, how this goes around. So here print data.head. Now data.head in Jupyter notebooks can be would directly display when you show in your cell. But here we need, I just thought to go a print here. It would be much better. Data.head would primarily just print five entries. You can change it by having it 10 or 9 or 11, any sort of things. Okay, and now this function dot info, data here represents the data. Now the this read csv function has put our data into a data structure. Data structures, I hope all of you know that linked list structures and all those sort of things. In a data structure known as data frame, pandas is mostly recognized with two data structures. One is the series and the other one is the data frame. Data frame is used for these data set incoming of a external file. Okay, it is a very useful data structure, and I believe pandas is famous because of this data structure only, because the processing here is just like processing a simple linear array. Okay, the info I would explain it when I would output it. And lastly, the visualization. So I think we should just run this bit. I open my terminal and we write here model python model.py for running any python library, python project, or all sort of things. Yeah, here is it. This line is due to our data dot head, and here you can see that class pandas.code.frame.data frame, and here we have 97 entries in our data set. It is a really small data set. In original you can have lakhs of entries or all sort. Okay, and next is data.info. Now this is a very useful thing. If you understand it carefully, it tells you about the data type, which would in future help you so consider this. For example, you have stored data of size of floors, and the form in which you have gave to the people to input it, you have by mistake considered that form tab to be textual input. So there is written a 4, but it would be understood as a 4 as a character and not as an integer or a float. So by seeing this data type, we would understand what is the problem. And in pandas and numpy, we can easily change the type of the data. And here 97 non null. Non null means that there is no empty or null entry. Null means that there is no entry, or the value is meaningless. Actually there is no value. Okay, and the last is the visualization. I have not shown you the visualization function. I believe I just show you that. So here is our visualization function. Okay, so in this function, as we can see, it would display our data, in which the data in a form of scatter plot. You can see it here, and this scatter plot is a function inside a function or class inside the SNS. Represent here cborn. X would represent the population, Y would represent the profit, and title, I have set population in 10,000 and profit in 10,000. That's totally fine. And in last you have to write plt.show. Now this plt.show would is almost for from Jupyter only, and you can see down here my a Jupyter logo has been there for my. Okay, any doubts until where we can get the data set? I will upload it, Anshul. It would be in on my GitHub ID. Okay, so now why data visualization is important. Now data visualization is important because now see, here we have a quite a set of uh, elements. We have here a quite, so we can see that a line, just for a reference, from a human mind perspective, not a computer mind, from a human mind perspective, we can say that a line can easily pass from here. uh, okay, but these things like this dot, these some of these are known as the outliers. Consider them, if I talk in the form of chemistry, consider them as exceptions. Okay, so these can be almost this point, especially this point, can never be fitted inside our data in our regression model any time, or in any regression model. From my experience, I can say that this can never be fitted in our model, in any type of model. Oh, that's a different thing, that you try to give it a knn of don't go into knn. I'm sorry, I won't go into that. And so so because of such things, our accuracy can never be 100%. In real life also, there is always an exception in any circumstance. Even a human can also be never 100% accurate about its domain or also. But the visualization would help us that yes, some line can go from here, and it should be going from here only. I would show the line at end that would pass the outputted line. Okay, so from here we are done with our dataset visualization, dataset importing, and we would next go up to another function. Any doubts up till here? Eh, Okay. Okay. So next is the cost function calculation. Now, what is a cost function? Now, you remember this? Uh, so the errors, the problems, the value differences in each here was considered to be the errors or the prediction differences from the real outputs. Combining all those, they would give some sort of cost function. Okay. In linear regression, we get a hypothesis. uh, okay, I would explain hypothesis a bit later. uh, okay, so in linear regression, we would get a hypothesis. In very simple words, the line equation which is first chosen by our model and then fit into our data set. Okay. In this hypothesis, we can have weights often represented by theta. Here is a theta. Okay. And with the change in theta, I have already explained that with change in our these parameters, the output would be obtained. Now the value obtained by this theta, by putting the value in the population, we obtain a profit value, that is our predicted value. Now, with all this knowledge, we can say that cost function, in simple terms, we can say that it is the difference between the predicted y and the given y. I will just show you the mathematical. So this is the cost function. Please don't get afraid from it. I would explain it line by line, word by word actually. So here h theta x, h represent hypothesis, theta represents are the parameter, x represents the population, y represent the real predicted profit. This whole combined would represent the predicted y. Okay. So every time we would minus our real y from the predicted y, and we would just square this, so that if answer is in anything is in minus, it could be easily plused. In mathematical terms, I'm sure you have read about the mean square error. So it is just sort of that thing. Are the objective, uh, the objective uh, of this cost function is to, the objective in machine learning algorithms is to reduce the cost function, or you say we need to minimize it to an optimal value, or to the maximum possible minimization we can do here. uh, as I have told you earlier, I think that m represents the number of entities or number of the data set examples. Here it is represented by y. I would just tell you what is x, y, and z. Just give me a minute. I have kept a little bits of notes also. So here, as you can easily see, m is the data size, the number of examples. For those who are very very new to Python and they have just knowledge of any other basic language, consider this as a structure data, and then we try to obtain a population, a value, a value of a structure, then another. Okay. And one really important thing I want to say here is that our x would be a matrix, yx would be a matrix, x, y, theta, all three would be matrices. So there's a something called vectorization, or just in simple words, understand that uh, it is really very easy. We save some for loops if we do matrix multiplications, or we play always with the matrices in case of data sets. Okay. So since x is only one value, and x is only one, So we would just append it with np dot ones, where ones here means that we have a 111 line of m data sets. Okay, and then there we have defined here theta. Now the initial value of theta can be oh my god, the time is going really fast. I'm sorry. So the initial value of theta would be 2 comma would be 0 0, although 0 0 is never recommended, but for initial case it is really good to have 0 0. uh, I would go a bit fast due to time. Okay, and next, as we can see, we have called our cost function. In cost function, y equals to y predict here in simple mathematical terms means here equals to y predicted equals to theta 1 x plus theta 2. Don't worry about these dot products. This lecture is more sort of a qualitative rather than quantitative perspectives of machine learning. I want you to just remember the flow of working. And now we will just print the cost function. So here we can see 32. 32 is a very high value of cost. At last we would get, I'm not sure, I would get about 5. Okay, so next we would go to we will go to the gradient descent. This was our hypothesis, which I told. And next is our gradient descent. I'm sorry if this lecture is going a bit long. I would take about 15 minutes, so I never expected it to go so long. Okay, and now what is gradient descent? uh, Consider that the algorithm got to know that cost function is really high, we have to do something, but what we have to do, that is defined by gradient descent. The here consider the point from summation till here. This is gradient descent, alpha 1 by m, where alpha is the learning rate. Gradient descent is a step after every cost function we find. We move our theta or parameters a step ahead or back depending on what our algorithm needs. Okay, so based on that, a descent would gradient descent is that step. Why alpha? The steps can be sometimes too large. Alpha is the called learning rate. What percentage of the step you want to move, in very simple words can be said, this what percentage you want to move is known by alpha. Okay, so here it is. Alpha should always be kept very small. Okay, it is always better. Next we would visualize. Next is visualizing the cost function. In this, don't worry about. Now we know now how to calculate one cost value. Okay, now this is just imaginary thetas we have taken, and they would be changed every time, and on the basis of that a cost function would be calculated, and I will show you how the cost function varies with the theta. Okay, uh, any doubts? Then we don't worry about mathematics. uh, Once the graphs come, it would be quite clear, crystal clear, to be exact. Okay, and now is the regression fit. Conv- uh, I would directly skip to regression fit. Regression fit, what I want to say is that the line fit. Okay, I'm hoping that the time won't be a factor for you all. So let me time is really far. Okay, okay, I would directly print all. So see here. Now basis on the theta of 0 and theta of 1 are cost function ranging from here to went till there. Now the best cost function here can be this one. This is the best cost function. In the complexer models, you can have local minimas or local maximas, but in a univariate linear regression, there would be only one global maximum. Global maxima and minima here means that the lowest point and the highest points. Okay, so this was the relation of cost function with theta. We would come to it later. So after a number of iterations, let me just. I'm hoping you can see it here easily. After number of iterations, this was the theta 1 and theta 2 value our algorithm got. According to our algorithm and the alpha and the number of iterations, this was the best theta it could possibly get. Okay. Now this is the theta and iterations. Based on the changing of theta and the number of iterations, our cost function went. Now some people might wonder, with more and more iterations our cost function would reduce and reduce to zero, but that's not the case. uh, the cost function can reduce to a certain point only. uh, After that it would just be see here. So for example, this is our minima, and we go and go more and more. There can be chance that it start to vibrate or move up and down, but the minimum, once minimum achieved, more and more iterations would just increase the model pressure and might affect your results. So this is the final regression line. So this is the best fit line our algorithm was able to find out. Okay, so as we saw in our this model fitting percentage, from it, the algorithm must have, with the cost function going down and down, the algorithm's line would have been getting better and better. Okay, so this is the best fit line. Now if for any higher secondary school mathematician, now this is very easy thing. So considering a points like 17.5, 17.5 means 17,500 number of people, the profit according to our algorithm would be somewhat around 17,000 rupees or dollar, whatever you want to say. Don't worry about these warnings. So this was the, now just for sake, if I input a population of 40, the profit would be 43,500. Thanks, Anshul. And so just a recap, this was our data set. This was the info about the data set. Okay, this was the final regression line we obtained, or the mathematical function we obtained. Okay, this is the test and visualization as you have seen earlier. I would just show you some convergence. This it is very important to see those. Here, if if you want a core of this 200 line or something code, this is the core. Gradient descent. Any mean square error is the not the only thing that finds the error, but but you can find error in any way. There would be some line accuracy is a different aspect, but gradient descent is one of the major things that would define. There are other types of also like Adam's algorithm, uh, which defines the gradient descent in a better way. In machine learn in deep learning, there are way more things to advance the gradient descents, to add epsilon and all those stuff, but I won't go into that. So I would just explain it as we all know about M. And next is, we would store the cost. This is because the cost with theta and the iterations we saw, this was just because we stored the cost, although it is not necessary, but it is better to visualize your cost. It would give you more better understanding about your model functioning and is your algorithm even working well or not. Okay, so these four lines under the iterations, uh, these just represent these three majorly they represent this. Okay, so I think with time, I think I should stop the coding perspective. Any doubts for coding part? Yeah, Russian, you have already worked with me. Okay. Okay, so I would next go into Azure. Now this one is for the ones who want to become, first of all, it is for the ones who want to become machine learning engineers in the coming time. This would be
Excuse
the
me,
compulsory
Intervi.
subject, I'm sure of that. And for the ones who want to build a business, who want to improve their websites, who want to focus more on business part rather than coding, Azure can give you what we can say is like no code uh, development. It is really good for machine learning. Today, I would just briefly explain you about how to develop a machine learning studio for Azure. Okay, and talking about some
Interpret, my voice is
things
audible.
more about Azure is that it
Hello.
provides a variety of services, from computing to storage to networking and all those stuffs. I hope most of you know about cloud computing. It is the hot topic nowadays, and it is getting really popular. Okay, so I will just explain it. So this would be the one, the screen as you open Azure. Just write Azure on your browser, and sign in is very easy, just like developing an email. And I have already signed in, so I would just straight away go into my portal. So this would be the main screen, or what we say is the portal when you arrive on Azure. So talking about what is a machine learning workspace, it can be considered as a logical container for machine learning assets. Uh, in a definition point of view, it provides a centralized space to work with all the things you create in your machine learning. And it also keeps the history of your training. Keeping the history of the training is one of the major things you would understand later. So let's straight dive into developing a machine. So once you come here, click on create a resource, search for machine learning, and you would be seeing here this icon. Uh, okay. and simply create. It is completely, if you want, it can it also have command line, but for beginners the GUI version is good enough. And one more thing, Azure is gives $200 credit free to students, so you can check that out. Okay. Azure uh, resource group. Now, what is resource group? It is a container which consists of the metadata of the logical groups of resources. Okay. uh, in financial terms, it provides a midway between the features or the resources you get and the subscription level you are on. Consider that that's totally fine. So I have just developed a one uh, time before, and you can have the workspace name as practice practice linear regression or anything of sort. And for beginners, nothing more has to be done. Just review and create your machine learning uh, environment or workspace would be developed. Okay. S- but uh, I won't review and create it here because it takes a lot of time and I'm already over time. I have already created one. I would show that it it takes about 10 minutes, I believe, depending on your processor. So I have developed this regression model, learning workspace. So this is the interface, and you have to directly go to the launch studio. It might take some time depending on your internet connection. Okay. It has some sort of computes also, but that would be just create it and go to next step. The basic compute would be easily formed for student level. And here you can see, here is the notebooks, automatic ML designers, dataset experiment, pipeline model, endpoints. So the asset and manage section, especially the manage section, is for the who want to develop something really big. This one is really good things. And the in I just inputted the notebook we recently developed. So here is a univariate regression model. So uh, it is very easy to develop the files here. And now what is this compute is that these are also the resources, what type of resources you are giving. Currently for the free version, the Azure is giving a little slow services because due to COVID reasons, the priority is for the health websites and the paid customers. What have 4 cores, 14 GB RAM and 20 GB hard disk is the things we have got in which we can work. Okay. So I've just uploaded it. We can easily upload files or create ones. And it also consists of Jupyter Lab. For those who know, Jupyter Lab is nothing, just a bigger and a better version of Jupyter, uh, in a easy sense. So this was our machine learning for Azure. if okay, so that's it from my side for the learning purposes. If there is any doubt, you can ask. Otherwise, I would move to the certification part. Okay. Okay, let's start for the certification process. Now, we could easily give certification on the basis of the forms filled, but then the certification would have no value. As you all know, webinars don't have much value. But after this, at least you can say, yes, you have done something or not. So, this is a ID of one of my friends. So, considering it as your ID, such as CO18325, that's my GitHub account. Why I'm doing this is because of Hacktoberfest. You make one pull request. I have already labeled my this repo as Hacktober accepted. So for those who are beginners, that would be really easy for them to make some PRs. At least they would easily start. And other than that, you can also, you know, give your PR in tech phantoms. But I would request all of you to have some, meaningful PRs. Tanvi Singh, why Azure? In the coming time, the development should be fast. Development, the deployment should be fast. Here, why Azure is come. If we want to say development and deployment, these are the two aspects Azure can do really really fast, and that would and cloud is the future. You can't have things on your systems after 5 years from now. No one would be using, and Azure in all at least I can say in machine learning, the interface, the CLI, command line interface, that is really good one. Okay. And so we have read this repository, uh, user, and now we go into repository. So here the very first one, I hope the it would be very first one, or just search univariate linear regression. Okay. And just fork it. Sorry for my internet connection. Next, go on to the events folder. As it is written GitHub username.md. Create a MD is the readme file. And one thing more, if you want to make big readme files, try it with Visual Studio Code. It is really good. Create new file. So her username is Simarpreet 27 and .md. Okay. The hash is for heading 1, double hash for heading 2, and so on till heading 7. And most of the HTML tags can be easily be worked in this readme files. Name, just enter your name and enter your email. Okay. And just write a few things about this event, or whatever you want to say. That's totally fine. If you leave it blank, that's also fine, but I would say if you write, it would be really good. Demo writing, and just preview it. You can see it there. The first hash, it h1. This is the hr depends to hr means a line. Hr tag means line. Okay. And just commit the new file. Go to pull, go, and then just create a go to go to the univariate linear regression, I mean back to the main repository, and make a pull request there, create pull request. So the pull request has been made. So now I will just show her Hacktoberfest file. So at last, you can see here she has made that created a pull request. I would mark that as Hacktober accepted and also merge it, and based on that I would give we would the Tech Phantom community would give the certification directly to the email, I think so. And you would also have one Hacktoberfest PR. You have just for the information sake, Hacktoberfest is a open source, event at a very large scale. This time, 70,000 people would get this tree or would plant a tree or get a shirt. And but this time they have made rules a bit strict to prevent the spams, and you have to make 4 relevant requests. I have also other repositories, but I would recommend you to focus more on giving your PR into Tech Phantoms or any other open source community. That's totally fine, because they have a better issues. There you have to some read their guidelines. Technically, this project was made for quite at basic level. In the real open source communities, you have to sometimes follow the paid guidelines for writing your codes and all those stuff. With this I end the pitching, and the it is and from my side. Abhir, if you want to add something or anyone have any doubt, I would be available here
Am
for
I audible?
10 to 15
Am I
minutes.
audible? Am I audible? Am I audible? Hello? Yeah. So, guys, am I audible, guys? Can anyone mention it on chat?
I hope you all of you get your certificates.
Yeah, fine. So I'm going to show you that what we at Tech Phantoms doing now, and let's see what Hacktoberfest we have. Like, what are we planning for Hacktoberfest? Let's see. So let me just go to our repo, that is github.com/tech hyphen phantoms. I'm sharing this. This is a repo link, and here we have we are building our Tech Phantoms website version 2. And if you are in React, then you can use this KLRD, that is a React state management library for React that we have made. It's a library for React. And AirJSON is the server storage system totally built on MongoDB. JSV Convert is a software, or you can say an app or tool where you can convert the JSON files to CSV files. And Phantom Buckets, this is actually a beginner-friendly repository where we are collecting the ideas that if you want ideas to get implemented in the real world, and we'll see that how the things are, and then you can go ahead with that. It's see, we have ideas like this. Somebody just posted it that just raise an issue over there, and things are fine. That we will merge those ideas. Let's see how many people. Yeah, if you have seen the language batch support, project proposal by Vinny, project proposal by Devanshu, like this, you have seen these are the things like we have selected, we'll add selected tags where if you have any project proposal, this is for the beginners. And if you are into the React, then we are focusing more on website. That means we are going to go to issues. First of all, you can see the issues. What are the issues we have? Let me tell you that all this website is participating in Hacktoberfest, and we have the labels, and also we are putting the labels on the PRs too. We have closed 100 PRs, and most of them were spammy, but most of them got merged too. If you observe, we have merged PRs too, and some were the spammy PRs, so it was bit complex task for us to like sort the spam PRs out. But fine, it's all great that we have actually sort the spammy PRs out. Let's see what have how you can contribute. Here are the development guidelines. We are like open to the master branch, like we are open for the contributions, and all the like you the deployed branch is master branch, and will any contribution if you make, you have to submit it to the development branch. Right? If you see the master branch is over here, and if you go for the development branch, it's actually 4 commits ahead and 4 commits behind master. So that's how the things are at Tech Phantoms. Even like the current situation of our repo looks like this. Let me show you. This is the current website that we are building, and it's on the build purpose, so we are not releasing it right now. And we are like having the whole backend is set up. We are now working on the front end part. So that's how the things are here at Tech Phantoms. And you can use like if you're at a par level in React, that you have some knowledge about React, then you can go for the scalard. That is a React global state management library. It has been used by BBC London too, and employees of BBC London, that and they have actually supported us for this. And we are actually building this side by side, and it's a if you are like into this as an open source project, and you can contribute here too if you are like totally in this open source world and in React. So that's all about Tech Phantoms. And also for such events that because we are actually planning to make students learn real world software development. So what happens sometimes GitHub is not so social friendly. That means we cannot put events poster or something like that on GitHub. So we are actually maintaining an Instagram profile, that is instagram.com/tech phantoms. So just here the Instagram profile is here. You can see all the events that we actually conduct, and some like what are the future events, and all the conducted events all are over here. So you can actually just give it a follow, or you can check it out over here. And yes, we are open for collabs also. If you want to do any collab over here with us, that's all fine. So that's about the Instagram handle, that we are actually making the thing socially alive, and also we are doing the development purpose. Great. So here's the Instagram handle which I'm sharing with you guys. So that's all about today's webinar, and I hope you learned a lot. And I would like to thank Inderpreet Singh for taking out the time for us in this webinar. And like you got the real view what is machine learning, on what, because most of the students get confused in this hype that machine learning is something new thing, but it is actually from since olden days, 1940s it has been there. So that it's getting hype today, but it has been there from like 1940s 30s. So it's I think it's a good time to learn machine learning. Also try to work on integrating machine learning and web part, that is actually make you more comfortable with React, and plus the backend part also, if you are working on something. Fine, that's all about Tech Phantoms and the open source community that we lead. And thank you guys for attending this web.
Thank you, everyone.